Hardibain Trevera Jasimito of STEM 25-1, here to explain ellipses and trying to solving a word problem relating to ellipses. Before we get into ellipses, let's define what is an ellipse. An ellipse is a closed curve defined as the set of all points where the sum of the distances from two fixed points called foci is constant. In layman's term, these are the types. It is basically a circle stretched out, and these are the formulas to take note before we solve a problem. And these are the parts of the ellipse, so we can visualize how the ellipse would even look like. So this is the center, and this is the vertices, this is the co-vertices, this is the foci, this is the major axis, this is the semi-major axis, this is the minor axis, this is the semi-minor axis, and this is the transverse axis. Now, moving on to solving a word problem. Our first problem is a whispering gallery is a vertical elliptical room where sound reflects off the walls. If two people stand at the foci of the elliptical room, 14 feet apart, any whispers made by one person is clearly heard by the other. If the width of the room is 48 feet, what is the length of the major axis and the formula? In this type of word problem, we need to separate the given to additional information. So our given is that it is a vertical elliptical room. It is a vertical elliptical room, and the foci are 14 feet apart, and the width of the room is 48 feet, the width being the minor axis, because we are searching for the major axis. So our given is it is a vertical elliptical room, vertical, that is not vertical, vertical, and that the 2C are 14 feet apart. The 2B are 48 feet apart, and we are searching for the major axis, so that would be 2A. Any additional information will be ignored, like this one. That's just basic physics of an elliptical room, so we ignore that. Okay. How do we start? So we are searching for the length of the major axis and the formula. So let's start with finding A. How do you find A? So we can use the given 2C equals 14, 2B equals 48. You can calculate C by 2C equals 14, and then you divide both sides by 2, and it will give you C is equals 7, because 14 divided by 2 is 7, and you can cancel this number 2 over here. So our C is equals 7, and we can remove this, and our same goes with the 2b. So 48 over 2, cancel this, 48 divided by 2, our b would be equals 24. We can search for a using the quadratic formula, or a is equals c squared, that is not a c, sorry, c squared plus b squared. We just have to substitute, so a is equals square root of c squared would be 49, and 24 squared would be 576. Yeah, it would be 576. So that would mean a is equals the square root of 49 plus 576. This would be 625. The square root of 625 is 25. So we can now fill in that a is equals 25 because we have formulated it over here using the b and the c. Okay, without that, we are searching first of all for the major axis. So to search for the major axis, we just have 2a, 2 times 25, that would be equal 50. So our 2a is equals 50. The formula would be just substitution, the standard formula for a vertical ellipse is x squared plus y squared over b squared, a squared equals 1, as you saw on the start of the video. This would be our standard formula. Substitution, so x squared plus y squared, substitute b squared with b squared, so 24 squared would be 576, and a squared would be 625 equals 1. Equals 1. That is our final answer for word formula, word problem number 1. Our second problem is a running track shaped like an ellipse. The length of the major axis is 120 meters and the minor axis is 80 meters. How far is each focus from the center of the track? So we're gonna start with a given, as we did last time. A given is that the major axis is 120 meters, and that the minor axis 2b is equals 80 meters. And how far is each focus from the center of the track? Meaning, what is c? Because if you visualize an ellipse, the center would be this and the foci would be here. It's asking how far each focus from the center. So it is asking for c. Okay. To search for C, we have to find A, B, and of course C, because we're searching for C. A and B. To find for A, we can do is dividing the 2A by 2. So 2A equals 120, as we did last time. Divide by 2, cancel that. So A is equals 60. So our A is equals 60 meters. You can ignore the unit temporarily, but I'm gonna include it either way. So 2b over 2 equals 80. 80. We're gonna cancel this, so b is equals 80 divided by 2 is 40. So b is equals 40 meters. Now we have to search for C. To search for C, we have a formula, or C squared is equals the square root, not the square root, C squared is equals A squared minus B squared. So C is equals 60 squared is 3,600, and minus 1,600, because that is, what they call this, the formula for that is 40 squared is 1600. C squared is equals 3,600 minus 1,600. So 3,600 minus 1,600, that would be 2,000 equals C squared. And we're gonna square root that both sides. So cancel. So C is equals square root of 2,000. What is the square root of 2,000? If I'm correct, 2,000 is not a perfect square, so we're just gonna take that. Square root of 2,000. Then that is our problem solved. How far is each focus from the center of the track? They are square root of 2,000 far away, meters. If you formulate it, let's assume that this track is horizontal. Let's assume that the track is horizontal. Then our center would be, let's say, at the origin. This would be about 60 meters. This is 40, and this from focus to center is square root of 2,000. And if we formulate it, it would be x squared plus y squared equals 1. And because this is a horizontal ellipse, we put the a here. A squared would be 3,600, and our b squared would be 1,600 equals 1. That is our formula for our last word problem. So if you have any trouble solving for a word problem including ellipse, you have to take note of a few things. You have to find the given, um, calculate or find A, B, and C, because those three are the one that's gonna help you solve any ellipse. They are the main components of the ellipse in numbers. And use formulas to find what you're looking for. Is it you're looking for the major axis, you're looking for the minor axis, are you looking for where the focus is, or are you looking just for the formula? They all contain at least A or B. That is our way of solving not just an ellipse, maybe even a parabola, or maybe even a hyperbola. Most likely a hyperbola, because hyperbolas are similar to ellipses. That is all for this word problem solving video, and good night.